Right. So the Geiger-Müller tube is basically what you see in all the movies, lah, right? You know, the thing that you've probably seen Monster Inc. before, you know, those yellow hazmat guys with the stick thing. That is basically a GM tube, guys. Hey, by the way, have you learned this in your school already? Did you watch the videos from last week? I assume you'll be a bit lost this week, right? So anyways, there are basically three forms, three radiations, right? And obviously each of every one of them have their own symbol. Alpha will be a tailed A, beta will be a tailed B, and gamma will be the exact same symbol as your breast cancer symbol. Hey, orange 三个礼拜你没有来咩? Oh, right. A few of you guys didn't bring the bloody book. 你有没有? Oh, okay. 就没有画那个图啊. Bloody hell. Right. Then after that, I mentioned also, guys, this is important where the element for each and every one of the symbols are very important. Alpha will usually be a helium-42, not usually, for sure be helium-42. You need to remember the 42 as well, guys. The beta will be 0, -1, and gamma will just be a ray because it is part of the electro. Oh my God, the door.
Why is there like no sound anymore?
Yeah, the alarm stopped there, right? Yeah, sorry about that. The alarm is the doorbell is stuck already, so a lot of students couldn't get in. But anyways, continuing from here, right, guys? The charges are very important, guys. Whenever we talk about the charges, it is directly related to the ionizing power, guys. Remember, I told you that alpha particles are positive 2 charge, right? It means to say it can ionize 2 negative charges. In layman terms, in other words, it can steal 2 negative charges from other neutral elements, guys. So in terms of charges, alpha will be the highest, and thus it has the strongest ionizing power. Beta will be -1 only, means to say it can steal 1 positive charge only. So that's why the ionizing power is relatively weaker. And of course, gamma has 0 charges, guys. So it is very weak in terms of ionizing power, guys. The mass-wise, like I mentioned last week, you do not need to remember the numbers, but you do need to remember which one is heavier and which one is the lightest one, guys. And I mean, it's common sense at this point, judging from the element itself, you can see which one is going to be the heavier element and which one is going to be the lighter element. There is definitely 0 mass for gamma because electromagnetic wave is a photon or a ray, guys. So there is 0 mass, guys. In terms of the range, which I think most of you guys don't see in your notebook for some reason, right? The range wise, alpha is the shortest range. That's why if you look at you remember the video from the Petri dish, right? The alpha can only travel a few cm away only, right? Whereas beta can travel a few meters away. Gamma is unlimited. It's yet again, it's like light, right? It can travel through space, vacuum at the speed of light and everything. So from here, the speed-wise, alpha is obviously the slowest, right? Because of its mass. Then gamma is obviously the fastest because yet again, yeah, just bullet with that. Just take it and thank you. Thank you, Natalie. Thank you very much. And then from here, guys, yeah, the speed of light, the SOL stands for speed of light, guys. Alpha can only travel 10% the speed of light. Beta can travel 90% the speed of light. And of course, gamma will travel the fastest because yet again, it is an electromagnetic wave, right? Then the next part here was the one that we talked a little bit more in terms of the discussion here. Penetration power-wise, always remember that gamma is going to penetrate through everything and will only be stopped by lead, guys. Lead is the only thing here. So meaning to say, right, in your exam, as soon as you see the word penetration and you see the word lead, right, they are most likely trying to test your understanding on gamma rays. Alternatively, if you see the word penetration and you see the word aluminium, or even wood, guys. I think I mentioned this last week. Aluminum, wood, they're trying to test your understanding on beta radiation, and alpha is the weakest among all the radiation. It cannot even penetrate through a thin layer of paper. Meaning to say, I put an A4 paper in between the radiation source and me, I'm going to be safe already, guys, because it cannot penetrate through any form of materials, basically. Okay. And after that, we also talked about the effects of the electrical charge here. If you notice, beta is obviously negatively charged by nature and alpha is definitely positively charged by nature, right? Obviously, what's going to happen is in the electric field where there are positive and negative charges, the beta will obviously be attracted towards the positive part because negative is attracted to positive, right? And the alpha will definitely be attracted to the negative part because positive will be attracted to negative. This is not the important part here, guys. Like I mentioned last week, the deviation of the beta is always going to be more than the alpha. Why again, guys? Why did the beta deviate more than the alpha? What was the reason behind it? Huh? Weight, very good. The mass, guys. Of course, in terms of the mass, alpha particles are much heavier, right? Because it's 4 helium-4 right? So obviously, it will take much more force to deviate it off. But for the same amount of force, beta is definitely going to deviate more because it is much lighter. For the same amount of force, imagine pushing a fat kid versus pushing a skinny kid, right? Then what's going to happen is the skinny kid is obviously going to be deviated further. The fat kid will definitely stand his ground better, right? Because it is just science, it's nothing. Oh, don't, yeah, leave it, just leave it there because the doorbell is chatat already. Yes, it's going to be a full house today, I assume. Yeah, anyway, please sit down. Bring out your book. Okay. Pencil case can forget, but you got bring your book or not? Here. Okay, whichever one that you like. Okay, guys, always remember, guys, alpha will deviate less because it is heavier. Beta is definitely going to deviate more because it is obviously much lighter. Then in terms of a magnetic field, guys, first question, what does this X mean again? Natalie, the magnetic field is going into the paper, and if the magnetic field is going into the paper, Noval, where's the north and where's the south again? Where is the north pole and where is the south pole for the magnetic field to be going into the paper? Where? What, faster? Yeah, the north is supposed to be in front of the screen and the south will be at the back of the screen, right? That's why the magnetic field will be going in, right? Orange, from here, which hand rule are we supposed to use to find the deviation again? What left? Fleming's left-hand rule, good. Why? Because we're looking for the force it's being deviated away from, right? Hey, where's Tristan now, by the way? Okay. Yeah, we're looking for the force, right? And the so-called current, guys, the so-called current is yet again based upon the fact that current flows from positive to negative and electron flows from negative to positive, right? I told you guys to associate alpha particles with current and beta particles with the electron as well, guys. And using Fleming's left-hand rule, you should be able to determine whether it will be deviating up or deviating down, right? Everyone crystal clear with this part here? Anyone's got any question from everything last week? From anything last week? Good, excellent. So if there's no questions, then moving on to the next part here. This is basically radioactive decay, guys. Now, what's going to happen is, right, whenever some isotope is unstable, right, they will usually go through the decay process, right, to stabilize it. Usually we say that the parent nucleus will decay to become the daughter nucleus to become more stable. So let's just say, in your exam, this will come out, by the way, let's just say today I have some random element here with 100 nucleon number and 50 proton number. Okay, let's just say this is the parent nuclei or whatever, right? And then I say it is unstable. If it is unstable, maybe it could go through alpha decay, it could go through beta decay, or it could go through gamma decay. But gamma decay is out of your syllabus, that is in A level, so you ignore that. That's most likely just going to be either alpha or beta decay. Okay, so if this thing is unstable and it's going to go through a decay, what's going to happen is, first things first is it will actually spit out a alpha particle. Let's say this is alpha decay, by the way. This is alpha decay. Okay, if it is going through an alpha decay, right, what's going to happen is it will actually spit out an alpha particle. So what's the element for an alpha particle again, Ian? Huh? What's the element for an alpha particle again? 4-2. What 4-2? Good, helium 4-2. The first thing first is going to spit out an alpha particle, which is helium 4-2. Then from there, obviously, it's going to change to a daughter nucleus already, right? Oh my God, how do you spell daughter again? Is this the right spelling? Feels weird. Is it a TH or HT? Oh, daughter, right? So from here, guys, it's going to go through a daughter. It's going to become a daughter nucleus, right? And it will become a more stable one. So once it becomes stable, right, you have to pay attention to the nucleon number and also the proton number, guys. The nucleon number and the proton number will be minusing off this 4 here. So from here, this will be 96, and this 50 will minus this 2 here, right, which will make it 48, and then this will become the more stable nuclei. Okay, from here, this is what we call the alpha decay process, guys. Have you guys learned this in school already, by the way? Yeah, it's basically the reason why they do this is just to become more stabilized, guys. It's just to become more stabilized. Similarly, if it goes through a beta decay, it will be the exact same process, right? So let's say I have element C right now with 50 and 25 here, right? If it goes through a beta decay, first things first is it's going to spit out a beta element, all right? Jialao, what's the beta element again? 0, -1, what? No, electron, right? Electron, right? From here, obviously, if it goes through a beta decay, it will become a daughter nucleus as well, right? So 50 minus 0 is still going to be 50 long. Is 25 minus 1, 24 here? Is this correct? Guys, if you learned this in school already, what's wrong with this equation? 24 minus 1 is 23. This is 25, by the way. Huh? Oh, right. Very good. That is the exact thing I'm looking for. Guys, bear in mind, a lot of you guys will make this mistake here. I'm going to think that, oh, 25 minus 1, then you're going to get 24, right? Guys, it is not, the real equation is not going to be like this. It's actually going to be 25 minus -1, which is actually going to be 26. Meaning here, this is not going to be 24. Instead, it should be 26 here, guys. Very important. I've seen this 1,000 times. Oh, some of you guys are going to make this mistake. I'm going to get 25 minus 1 and then going to give me 24. Then you will effectively lose the most easy mark here, guys. Understand that the beta is going to be 0, -1. It's going to be negative, guys, which will give you 26 at the end of the day. Anyone don't know what I'm talking about for this part here? Very important. Like I see a lot of students make this mistake. It's a very simple mistake, but it is definitely going to cost you. Excellent. Okay, if you have no questions, then looking back at the notes itself, exercise time. Oh, I want to tell you a story as well for this chapter here. You know, by right, guys, in your exam, usually, right, they'll give you something like this. They'll say that, okay, this is an alpha decay. Then they'll say that this will be element X, whatever it is, right? It will become some random element. And then all you need to do is fill in these numbers and fill in this number, and this element here, okay? Last year, for some God-forsaken reason, right, they decided to change the syllabus, you know, and then so happened, right, 1 week before the exam, I dreamt about them changing the way they structure the question. You know, I dreamt about, this is seriously like a message, you know, that could call me a messiah at this point already. So what happened was, right, I dreamt about, because in SPM, usually, right, how we're supposed to find this is, right, we need to find out, okay, from here, this is how we do it in SPM, guys. So basically, I know that this is going to be an alpha decay, right? So first thing first, it's going to be helium 4 too long. Then after that, we have to find that this is going to be 0206 and this is supposed to be 82. Then we're supposed to find the periodic table of which element has a proton of 82. Then we're supposed to write down whatever element that is in the exam, you know. Never in IGCSEs have they ever asked it this way, because most of the time they'll tell you that, okay, this is some random element. Let's say it's like element X or whatever. You don't have to find it. But in last year, I think in the October-November batch, they actually changed it and they asked you to find what the element is based on the periodic table. So if this year there was the same thing as well, right? I want you to know that, let's imagine the periodic table here. Okay. It's very small, huh? I mean, oh my God, what the? How do I make this picture bigger? So let's say, guys, just now what we were looking for. If you look at your notes, guys, the PO was 84, right? So first things first, you want to check whether this periodic table is the exact same thing or not. You see here, this PO is going to be 84. For those who are sitting at the back, maybe it's a bit harder to see. How do I scroll into this damn picture? Okay, forget this. How do I scroll into this bigger picture here? This was. Depending on the question, they might, guys. Let me just go find one of the periodic table, guys. If you see here, guys, you see that the PO, this is too small as well. If you see, just go find the periodic table. Okay, first things first is you want to identify whether this 84 is going to be the proton number, and the best way to look at it is find the if you look at your notes, PO is 21084, right? Then you look at this periodic table here. Is the PO 84? Yes, it is 84, meaning to say this is according to the proton number one. And if you know that it's going to decay 42 helium, right? 42 helium, and it's going to form 20682, right? So you're finding 82. Oh, this is PB. So from here, I know that, okay, after this PO goes through a alpha decay, it is actually going to become PB as the new element, guys. So meaning to say, what? Wait, let me reconnect my iPad. What? Oh my God, almost ended the meeting for everyone. Meaning to say, guys, from here, if we know that we identify that this is going to be PB, guys, you're actually supposed to write the word PB here as the new element after it has decayed away, guys. Does anyone don't understand what I'm talking about? If the question does not give you the element, you need to refer to the periodic table to find what element it is going to be according to the proton number, guys. Everyone understand what I'm talking about? Everyone crystal clear? Okay. Yes. Yeah.
You dream about it, the guy telling you that he changed one, like he did the thing.
No. I dreamt about the question paper being a different format.
You just see like that.
Yeah, and then I see like, oh, I need to. It was like literally 1 or 2 weeks before this exam. And I see like, hey, how come the symbol is missing one? Then I have to find the symbol from the periodic table itself. Then I just casually say, like, guys, I had a dream last night. Then I said that, you know, this happened. So in case it came out, right, please make sure you know how to do it. And then seriously, it came out. Then I realized I messaging, wow, your dream came true, your hearing came true, and all that kind of shit. You know, I'm like, I'm a messiah, bro. They call me the messenger of God. You know, so guys, please make sure you know how to find it, guys. All right. So yeah, this is essentially what it's supposed to do. By definition, guys, look here. A radioisotope, an unstable arrangement of neutrons and protons in a nucleus, is altered to become more stable. Basically, it decays to become more stable. We say that the parent nucleus becomes a daughter nucleus. Oh my God, it was HT. Nucleus and a particle, the decay product. Okay, so this is the parent nucleus, this is the decay product, and this is the daughter nucleus, guys. Very important, you need to know this. Parent, decay product, and daughter. Okay. Okay. If you're done writing everything down, please attempt the 4 things here. For the symbol wise, you can just ignore it for now. I'll just write A, B, C, D, E, F, G element, right? But in the exam comes, if they really do give you the elements to look for, you have to find it according to the periodic table of X. Yeah, not all X element for sure. And your head, at least write A, B, C lah. At least write A, B, C lah. Okay, guys, 2 minutes to finish this. Faster, let's go on. Don't waste time. Oh, for those who are done with the alpha decay one, you can flip to the back and do the beta decay, guys.
Electron capture.
Sorry? Oh, electron capture, ignore it. It's not in your syllabus. So just skip that whole thing. Only do the beta decay part.
So what I see happening?
What?
I see something happening.
Some of the good. What's happening? Expansion. Hey guys, those that are going to Sunway, I'm going to create a list tonight on WhatsApp, guys. Fill in your name to double confirm that you're going to be going. And then those that want us to get a ticket, I think we'll be collecting the fee from you guys, the remaining fees. Then we're going to buy the tickets online straight away already, guys. Yeah, so
You sponsor 50 ringgit.
yes.
Even if you get an F, right?
Did you get an F? How much do you get in your exam?
We start first. Walao.
Oh my God.
You saw first? Oh, you also got an F.
Oh my God, you got an F, seriously? What the? You also F, Hey, let me tell you guys, if you are if you're failing the exam right now, right, you better. Okay, let me tell you, this is the honest truth, okay? It's time for a little life lessons from Mr. Gabriel again. Now, if you look at the time right now, right, the dates and everything, now it's June, right? Meaning you have June, July, August, and September to change from a F that stands for until you're an A, okay? All right, I tell you what, guys, seriously, it sounds funny and it sounds unbelievable, right? I've seen countless students go from fail to an A in these 4 months. But in these 4 months, right, you cannot lie to yourself. You must identify that, number one, you are definitely shit. That's why you failed the exam, right? Then after that, once you identify the problem, the next thing is to come up with a solution for the problem, right? What's going to be the solution? I tell you, it's the easiest solution that all of you guys can do, even if you're mentally challenged. What is it? You do the past year papers. Okay, if you find it hard to do the past year papers, right? Sorry, everyone, you have to buy the book already, like Marcus here. You have to buy the topical questions, because the topical questions, I have everything explained on YouTube already. If you don't want to do the topical, you straight away start doing the past year papers. It's going to be good enough, because I can tell you every year in, year out, right, IGCSEs is the same damn questions with a different number, with a different way to structure the question only, okay? It's the same damn thing. If you can do well in your past year papers, you're definitely not going to do well on the first paper. Let's say today you say that, okay, I identified that I'm shit already, it's time to work hard. It's definitely doable, guys. Once you work hard, right, you do the first past year paper, you'll probably score like 50 out of 100, right? Which is fine, right? And if you cannot even do the first past year paper, let me tell you, straight away look at the past year paper, answer the question, look at the mark scheme, straight away you understand what you want, right? You want to do it side by side, past year paper, mark scheme, past year paper, mark scheme, one question at a time, right? The first time you do it will probably take you, I don't know, 2.5 hours to complete one paper, but I can guarantee you, right, it's just going to become easier. The first one will be 2.5 hours, the next one will be 2 hours, 15 minutes, the next one will be 2 hours, then will be 1 hour and 30 minutes, and so on and so on and so on. But just like Jesus, right, I can only help you if you help yourself. If you don't want to help yourself, right, then let me tell you guys, this is my specialty. If you don't care, I don't care even more, guys. But I can tell you, if you care, right, and you ask all the questions, preferably not before the day of your exam, because on the day right before the St. John's exam, I received quite a few questions from quite a few people asking me to do some questions. Then I know that this is the only time that you're going to be doing the question paper. I can tell you that it's definitely not going to work. It's like lying to yourself. It's like you're on the last breath of air in water and say like, I'm going to swim to the top and grasp one more air, I'm going to dive down. You're dead already, guys. You're already dead. You're not going to get the last grasp of air. But I can tell you, if you really start to struggle now, right, you start doing your past year papers and you actually do everything and understand and ask what you don't understand, right, is definitely able to score in here. Not just for physics, for every other subject, but you must take the initiation to start torturing yourself now. So, guys, for those who have failed the paper, maybe how much you got? Fail also, is it? You didn't even come for the exam,
You didn't even check the marks.
厉害. You B B or C? B, A. You where?
70.
Oh, not bad. Wow. You
73.
Oh, not bad also. You haven't got your paper yet, right? You haven't done your paper, right? You got 7. How much? 85, 84. 84. B. B. Oh, okay, not too bad. Not too bad at all. Definitely better than this assholes here.
It's bad, very bad, don't check. Very bad.
Okay, guys. So, guys, please heed my warning. It's definitely doable. I've seen countless students do it, but you have to try it for yourself. Okay. Yeah. Okay, guys. Anyways.
This electron one only.
Yeah. Okay, everyone, stop talking. Hello, stop talking. Pay attention. Oi, 頂你個肺，叫你唔好講，我講。 Last pay attention. Okay, get this. Make sure you got everything correct. Our this is obviously all of it is going to be helium 42, and all of it will be 234, 90, 234, and 88, 218, and 84. And then you could just write any random element lah, A, B, C lah, right? But bear in mind that there are definitely different elements, so don't just write X, 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 right? Then after that, the beta decay one will be the exact same thing as well. All of it will be 0, -1 here, and then from here it will be 14, 7, 90, 39, 40, 20, 13. Electron capture is the other way around. Instead of decaying at the beta, it's absorbing one beta, but it's out of your syllabus already. So just ignore it. So this one here, so like A, B, C, D. Okay. Yeah. Anyone's got any questions here? Anyone got it wrong for this parts here? I think should be quite standard 1 maths, right? I think everyone should get this correct. It is. Okay, yeah, then this part just ignore it. Let's move on. Let's move on back to this part here, guys. Actually, I'll come back to this. Sorry, move on to 5.2. Move on to 5.2, which is the half-life part, guys. Oh, I remember. I think there was something wrong with the numbering.
Wait, for next year they are introducing
Planets. Yeah.
Then are they removing any?
No.
They just adding.
Yeah. You know, astrology, right, is one of my least favorite topic because when I teach, sometimes I get requests to teach the lower years 8 and 9, you know. I don't usually take up the 8 and 9 students, but when they do, right, I'm like, oh, do I look at the astrology chapter, talking about planets, which one comes first and which one comes last? I have absolutely no idea which one comes first and which one comes last. And I always tell the students, like, this chapter, not important one, in your IGCSE, it's not even us. So just ignore this chapter. Now they changed it and added in, so I have to find out a way to help the students learn about astrology. I created the notes already, but there's absolutely no exercises except for the different O levels and GCSE syllabus. But it's going to be a fun time for the year 10s. You guys are lucky for the year 11s.
No, but for like chemistry, they are removing the whole item.
Is it?
Yeah.
Oh, interesting.
So like, physics one half, chemistry one easier. So drop physics and chemistry.
Interesting. But anyways, okay, everyone pay attention. This is going to be a relatively easy chapter as well. This chapter you cannot lose marks. It is like basic understanding already at this point. Have you guys ever heard of carbon dating before?
Carbon dating.
Yeah, it's not dating a carbon if that's what you're thinking about. It's carbon dating is essentially the method to determine how old a fossil bone is. For example, you know, the archaeologists, they dig up the bone, then they say that, oh, this bone is like 10 million years old. Oh, this bone is like 5 million years old. Or this bone is whatever, how much years old, right? How do you think they got to know how old the bone is?
Calculate the half-life.
Yes, it is through the calculation of the half-life of the carbon footprint, not carbon footprint, the carbon in the bone itself. Okay, so let's just say for example, right, if today, right, I have a bone, right, a bone that starts off with 100%. Oh shit! Yes, this is a bone. Right? I mean, bone. Right. So right, this is a bone, right? So let's say, for example, everyone pay attention, joke aside, everyone pay attention now, guys. So let's say, right, this bone starts off with 100% of carbon, right? The carbon for carbon dating, right? After a certain amount of time, the carbon inside is actually going to decay away. Okay, so let's just say today I say that the half-life of a carbon is, for ease of calculation, it might be more, it might be less, I don't know how many years it is. Let's just say the half-life of a carbon is 1,000 years. Okay, so what happens is, right, initially at right now, let's say it's when year 2000 lah, right? After 1,000 years, after 1,000 years has passed by, year 3000, this bone, right, when they do the calculation and everything, right, it will be only left with 50% of the carbon only. After another 1,000 years that goes by, it will be left with half of that current amount, which is not zero, guys. A lot of students get this wrong. They think that it's 150, then it's zero. It will never be that case because it's only half of the current amount. So if this current amount is 50, right, the next half will be 25 lor. After another 1,000 years that goes by, it will be 12.5, and then 1,000 another years that goes by, it will be 6.25, and so on and so on and so on, right? So let's just say after a lot of years later, right, they dig up a bone and then they find that, oh, there's only 6.25% of the carbon left only. Then from here, they can actually do carbon dating to backtrack everything, right? Backtrack everything back to the start law. So if I know that every 1,000 years, it goes through one half-life, right? Then from here, 1,000, 1,000, 1,000, sorry, missed out this one. This one another 1,000, and then this one another 1,000 here, right? From here, I can tell that if I find the bone that is 6.25% left of the carbon, I know that this bone is at least 4,000 years old. And this is essentially how they do carbon dating for the dinosaurs. You understand what I'm talking about, everyone? Today, what we're going to learn is we're going to do the calculation for half-life, okay? So if you look at the layman terms, guys, if you look at the layman terms, half-life of a radioisotope is the time taken for half the nuclei present at any given time, not from the original time, at any present time to decay away, right? Some nuclei are more stable than others. If they are more stable, usually they'll have a longer half-life. If they are less stable, they'll have a shorter half-life, okay? In layman terms, basically, it's the time taken for one particle to reach half of its units, which, for example, could be 10 to 5. Now, in terms of half-life, guys, usually in terms of half-life, they have units for this. Half-life, let's just say, right, this object here starts off with 100 counts per minute, guys. It's usually counts per minute, or sometimes it could be counts per second, or very rarely it will be counts per hour, guys. This counts per minute is basically the units for the radioactive substance, guys, right? So let's say if I say that, after one half-life, which is 1,000 years, it will be only left with 500 counts per minute. After another half-life, it will be 250 counts per minute. After another half-life, it will be 125 counts per minute, and so on and so on and so on. Counts per minute, but it's not always counts per minute. There's no standard units for radiation. It could be counts per minute, it could be counts per second, but just bear in mind that it's just a unit to measure how much radiation is present at that specific time. Okay, so let's just say let's do the first question together, guys, and I want you guys to attempt question 2 and 3 yourself. If you look at this first question here, which is definitely not an IGCSE question, it's just for understanding signaling. It says that a substance has a half-life of 30 minutes. What fraction of the atom will not have decayed after 1 hour? So if the question starts off like this, right, I don't know how much is the count per minute, but I know for a fact that it's definitely going to start off with 100%, right? And if I identify that the half-life is 30 minutes, it means to say after 30 minutes, it will be left with 50%. After another 30 minutes, which is essentially 1 hour, it will be only left with 25%. So how much fraction of the atom will be left with? It will be left with 1/4 of it, right? Because 25% is a quarter, right? So this is how you're supposed to do this, guys. You are highly encouraged to draw the arrow diagram so that you can visualize how much is left and how much has decayed away, guys. All right, everyone. Try attempt question 2 and 3. I'll give you 5 minutes. Question 2 is a trick question. Question 3 is a little bit more on understanding, guys. Try to do this right now and let me know if you have the answers. While I go get water. 5 minutes, guys. Everyone, please attempt the question.
Orange. Huh? Dia ni MS ni negatif.
So,
midday is 12 o'clock.
yes. Oh, that's the question. 1/2? What do you mean? What do you mean 1/2, Shannon? Is that your answer? What fraction will have decayed away? It's wrong. That's your answer to question number 2. Brian is not here today. He says he's going for dinner. What does that mean?
You don't know what cat means.
I only know no cap.
No cat. Opposite of no cat.
Oh my god. So where is he actually going?
I don't know.
What the hell, this guy? Public holiday, out for fun.
Go celebrate the king.
Was he invited to his VVIP party?
Yeah, they want you open.
我问 where 你们这帮开的呀？ Midday.
Meat roll, meat, yeah, you are real. I'll take it.
Oh, wow. Hi. Can I help you? What?
1 hour. Oh.
You understand this part?
First one. Why would this thing is called? This half-life. Is it possible to be 200? But how do they measure the
This is in terms of percent. 200 could be 100%.
Oh.
Yeah, I mean, so this is in terms of percent. This is in terms of radiation, the count rate.
I see. So I can use this as a
Yeah. Do that. 200 goes just go 100. From 200 goes to 100. You don't have to go percent anymore already. That's a count rate. So now. This is wrong, by the way. Yeah, this is correct already. This is wrong. Wow. How do you think about the money? We started off with 200 only though. How do you get it from there? Tell me. Why is it 925? Which scenario is 925? What's your answer? Wow, so specific. Wow. So my count is already 100% tricky. So the 50% would be 100 counts per minute, 25% would be 50 counts per minute. Oh, excellent. Very good. You talk about
excuse me.
Very good. Very good. Very good. Very good. Very good. Okay, everyone. Time's up. Let's go through the question together. Okay, everyone. I see one of the most misunderstood concept here, guys. Hey, you know just now? Hey, everyone, pay attention now. You know just now I said that the units is counts per minute, right? I see a lot of you guys thinking that this is the percentage. You know, like just now here, why we do it in terms of percentage is because I don't know the starting number of the count rate, right? I don't know the starting number. So that's why I need to figure it out in terms of percentage. But here in this question number 3, it already gives you the count rate already. Meaning to say this radioactive substance is emitting 200 counts per minute. You know, this 200 counts per minute is the original 100% already. You get what I mean? It starts off with 200 counts per minute already. You get what I mean? Okay, never mind. Let me do question number 2 first, then we'll do question number 3 together. Okay, if you look at this question here, most of you guys answered 1/4, which is absolutely the wrong answer because it is will have decayed away, guys. 1/4 is basically what is left, right? Right. So guys, in this question here, it says that it has a, hey, look at this question here. Another substance has a half-life of 3 hours. So this is the first piece of information I know. It decays by half every 3 hours. What fraction of the atom will have decayed after 6 hours? I don't know how much it started off, right? Then I'm just going to write in terms of percentage of, for sure it starts off with 100%, right? After one half-life, which was 3 hours, it would have decayed to 50%. After another half-life, it would have decayed another 25%, right? So this is the percentage that is left after 2 half-life, which is 6 hours. So how much will have decayed away? 75% of it will have decayed away, right? Which is essentially 3/4 instead, guys. Everyone understand what I'm talking about for this part here? Right. I think everyone should have been able to do this, right? Exactly. Right. Then question number 3 here. So this one is more realistic to a real IGCSE question, guys. It says that it starts off with 200 counts per minute, which is the units of the radiation at midday, which is at 12 p.m., right? Not 5 p.m., right? Then at 3:00, she finds that this has dropped to 25 counts per minute. 25 counts per minute is at 3:00, right? So if I draw the arrow chart, guys, it will be something like this, right? At 200 counts per minute. It starts off at 12 p.m., right? Then at 3:00, I don't know how many half-life we went through. It was only 25 counts per minute. Right. From here, I can kind of draw the arrows, right? After one half-life, for sure, this will be 100 counts per minute, right? After another half-life, this will have been 50 counts per minute, right? After the final half-life, it would have reached 25 counts per minute, right? So from here, guys, once you draw this arrow, hey, everyone pay attention to this, you're going to need this. Once you draw this arrow, right, you ask yourself, how many half-life did it take in a span of 3 hours? It took 1 half-life, 2 half-life, and 3 half-life. If 3 half-life took a span of 3 hours, then obviously 1 half-life would have only been 1 hour, right? Which makes sense, right? Because if now you draw a timetable, 1 p.m., this will be 100, 2 p.m., this will be 50, and then 3 p.m. it will be going to 25 counts per minute, right? So this is how you're supposed to draw the arrow charts, guys. If you draw the arrow charts properly, it will be a little bit more easier to solve. But of course, you need to understand the question now. How many of you guys got 1 hour? Oh, so it was you lah. Then you got it yourself, right? Marcus, did you get it yourself for this 1 hour? How? Was it you? You got what? 2,000. Oh, for right, you got it. How did you end up 2,000? Can you explain it? How did you end up with 2,000? Everyone understand this? Everyone clear with this right now? Okay, now talking about half-life, guys. Yeah, I want to talk about one thing as well, guys. If you look back at your previous notes, guys, you'll notice that this is something that I purposely skipped, guys. You realize that in 5.1, the background radiation, I totally ignored it and didn't explain anything at all. Probably most of you guys did not even notice that it was skipped, right? Guys, what is background radiation? Background radiation, guys, there's 2 key characteristics of background radiation. Number 1, it is always present. And number 2, it is definitely random, guys. What do I mean by that? What is actually background radiation? Background radiation basically states that no matter where you go, in the air or in the sky or in the ground, right, there is a form of radiation. And usually, background radiation is somewhere around 30 counts per minute. 30 counts per minute. By right, we know that radiation is harmful, right? So how come we're not dying from this 30 counts per minute? It's because the human body has already adopted to live in a little bit background radiation. No matter where you go, for sure there's going to be some form of background radiation, okay? So where do these background radiation come from? It could come from mainly 4 sources, guys. If you look at the statement here, it says that the small amount of radiation around us at all times because the radioactive material in the environment, okay? It may come from natural sources such as the soil or the rocks, the air, the building materials, food and drinks, and even outer space. Outer space is the cosmic rays that are consistently beaming down onto Earth. Now, in your IGCSE syllabus, guys, they will usually ask you, on top of your half-life radiation count, they'll include the background radiation count as well. I'll show you the example later, but for now, you just need to know that background radiation is forever around us. We are not going to die from this background radiation, and it will usually come from these sources here. It will come from the space, rocks, soil, building materials, and even some of your food and drinks. A funny story, guys, like in China, right? Let's say, for example, today, if let's say, okay, GTG find me 上市 is in the stock market, right? I want to build a new building in China, this as my headquarters, okay? So, if let's say we build a new building headquarters, the standard practice in China is, right, after the building is completed, unlike in Malaysia, when they pass the key, then you're going to start living inside, right? In China, they'll leave the building empty for 2 years after completion. Why do you think that's the case? Yeah, there's a lot of radiation going on. This is hearsay, of course, right? So my understanding is, I know that probably they cut a little bit corners here and there, right? So the building materials probably have a relatively higher radiation count than the supposedly standard allowable amount, right? So as soon as the building is done, which is obviously made from soil, rock, and building materials, right? There's too much radiation going on, which is actually harmful for the buildings, for the human beings in the building. That's why they choose to let it decay away first before going into the buildings. This is a standard practice in China. You can if any one of your parents are working with anyone in China, usually you can ask. For me, how I know about this is because my girlfriend used to work at WeChat. Hanson basically, right? And then when they expanded like crazy a few years ago, then they had to buy a new building to locate for the new staff, right? As soon as the building is done already, my girlfriend asked, hey, how come we're not going into the new building? Oh, we need to leave it for 2 years first. And she never bothered to ask, right? But now that I think about it, yeah, I guess it kind of makes sense, right? But at least it makes sense in my head, which is easy to remember, guys. From here, you need to remember the background radiation. Usually, they'll ask you for two examples of background radiation in your exam, which you're definitely going to answer soil, rock, or building materials, which is the easiest one because essentially the building materials, all these things is from the soils and the rocks, right? And cement and everything, right? And the last one is going to be cosmic rays. What I personally like to answer the most is cosmic rays responsible for the background radiation. Very easy to remember, right? The rays from outer space is definitely radioactive or cosmetic or cosmetic. Definitely not the word, but cosmic rays, you get what I mean, right? The ones that are spraying down, right? So building materials, guys, and cosmic rays, all right? Very important. Oh, and one more thing, they'll also ask you about the characteristics of background radiation. Why is it always present? It's because everything around us has radiation. And then why is it random? It's because the background radiation fluctuates up and down. At one point, it could be 30, next point 31, 32, then become 28, 29, then 32, then 30, and so on. It always fluctuates up and down. It's absolutely random. You cannot tell what's the next number, okay? So it's always present and always random. Okay. Then the final part of our notes before we get thrown into the exercises. Yeah, if you look at the safety precautions here, is quite common sense, I would say, but it's definitely worth highlighting, right? In terms of safety precautions, how are you supposed to handle all these radioactive materials is obviously number one. All radioactive materials should be stored in a lead container in a locked cabinet, right? Why must it be lead container again? Good, very good, because even gamma radiation cannot go through lead. That's why the lead containers are essential. It's picked up with your tongs and not your feet. You know, okay, before I talk about the feet part, guys, all you guys know what a tong is, right? Is that stupid clip thing that has super long and then you clip, guys. So that thing is called a tong, right? Obviously, you're not supposed to handle. Yeah, but it's the different tong that you're thinking about as well, right? But the tong is the clip thing, yeah, guys, right? Don't have any funny ideas, right? Funny story, tongs is actually slippers in Australia as well, which I found very weird because some of my friends when I was younger, they studied in Australia and say, hey, nice tongs, and I'm like, what are you talking about? And it's like, oh, tongs are slippers apparently in Australia. I don't know if it was trolling me or whatever, but anyhow, but anyways, yeah, it should definitely be handled with the tongs, not your feet, right? And the reason why, guys, you see the word feet there is not even your hands. Why is your feet? It's because I've actually cross-referenced a few materials online, and they always use the word feet instead of your hands. I mean, like, if you're a logical human, not a chimpanzee or an ape, right? If you drop something down on the floor, naturally you're going to use your hands to grab it, right? Not your damn feet, right? But surprisingly, right, after cross-referencing a few sites online, I see that they all use the word feet. I'm like, oh, not your feet then. It is. That's why it's your feet. I mean, I can get the some of you use your legs and you grab the thing. I do that too, right? But naturally, first instinct is to use your hands, right? But yeah, but anyhow, you get the idea. Then, of course, the next part here is it should be kept away from your body, not pointed at anyone because obviously it's radioactive, right? And it should be left out of your container as short time as possible because the radiation is going to increase more as you leave it out more, guys. So by right, the general practice is you want to keep it as soon as you're done with it because you don't want any radiation coming along. And especially if it's ionizing radiation, guys. So the final part here, alpha, beta, and gamma radiation are all ionizing radiation, which can definitely damage living cells. This happens because of the ionizing radiation, which can break molecules into bits called ions. Guys, if you recall just now, I said that alpha has the strongest ionizing power because it's +2, right? Means to say it can steal other people's negative charges, right? And like I mentioned last week, like the cartoons, they start melting away after they're exposed to radiation. I assume it's because the whole molecular structure of the body is unstable already. The negative charges are all cancelling off each other, stealing other positive charges and so on. That's why the whole body structure is melting away. So this is what we call ionizing radiation, guys. These ions can definitely take part in other chemical reactions in the living cell, right? Like for example, if these guys are like dating already, right? Then after that, I introduce one alpha particle, which is obviously a stronger positive guy, right? So if you steal your girlfriend already, what they're going to do, these guys are going to steal other people's girlfriends, right? Which is a chemical reaction of its own, guys. So yeah. And of course, the hazards include radiation burn, hair loss, cancer, reproductive sterility. For the men, be careful, right? And of course, mutation in your offspring. Just that when we say the X-Men, right, it's not the ones that you see in the cartoons, got Cyclops with laser beam, got the Charles Xavier. This X-Men, I have like one eye at the bottom here, and then probably one more hand here, or no hand. That kind of X-Men, guys. It's like yes, it's definitely a defect, a defected mutant. Yeah. Yeah, but you guys get the idea, huh? These are all the problems that could be caused due to the radiation. Okay, everyone? Oh, is it all available already? Good. If it's all on your notes already, right, guys, you see the next 2 pages from this here. Finish it as homework and exercise right now. If you finish it right now, there's no homework. If you don't finish it, it's going to be homework. We'll discuss the answers for this next week, guys. Start doing it right now with the little amount of time you have left. Yes, Natalie. Exactly. 100%. You just take the last root for. Yeah, I guess the lead is like 1 cm. If it is 1 cm thick, it's definitely possible. But if the lead is thick enough, it's not going to be right. You can measure it through 100%. At least not in the last, not 100%. Textbook, okay, I'll let you know. I've actually never read the textbook before. Even when I was young. So, but I can tell you, my style is to answer this 100%. If I see that here, that gamma is not right. Unless they say that the gamma is very thin. Sorry, the lead is very thin. If the lead is very thin, then yes, it could be a possibility to send it to. Why do you look so tired? You're getting really I think it's the online ticket that we go there buy is more expensive. I'll check right now actually.
Now holiday will be price.
Sure.
Most probably scam.
Scam alert. Way Lagoon tickets from 150. 140块啊，变到 ，Oh my God， 险哦。哎 ，There should be another website, right?
稍微
So you got subsidy for good results. What is good result? B above. Of course.
B above can negotiate a little bit more, but definitely not the full price. F 给你50块都算好了哦。他们就是打掉你们的 subsidy 了。
Not bad.
Hey, really 140 already? What the hell?
Save 6% from 150, 140.
贵了了喂。
我们那时候去便宜，说我们那时候去便宜，
你没有去看那时候我们去咯？
没有
没有加包没有，他没有去啊，不是吗？
I saw that it was 120 something only though. Weird. Was it from Coop?
Holiday price.
Yeah, maybe it's a holiday price. I didn't know that this week was
And then
government
summer,
holiday.
I think you're gonna need to buy the express pass.
什么你
holiday 啊？
那时候
我们那时候没有，因为那时候是 working day 啊。
我是 express。
express
就是你看 Q，
是啊，然后你读那种不同，
那个统计来啊。
真的140万
哦，
GG。
那个要填吗？有一些超。
有些人超。
Yeah, all under 80.
What's considered to be a child? Wow, it's gonna be 140. Yeah, a bit more expensive.
Under 40, both the mean.
For the memes.
I don't think I can borrow my father go for too expensive already.
It's okay.
Just
enjoy
use phone for the roof.
Orange. We can have it once.
那时候我们去的。
怎么抓住他手哦 ？What the hell？ 他的手是给他女朋友签的 ，OK？ Unless, oh, it's LGBT month, right? Anyone of you guys want to come out of the closet this month? What? Anyone want to come out of the closet this month? You know it's LGBT month, right? Gay Pride month, right?
Come out of the closet, it's kind of like review.
Time to show my rainbows, right? I used to only be interested in women, but now I'm interested in men to widen the scope of availability.
So far by gay radiation.
Oh. Good, but I will only give you 1 mark. You need to say why. Why would the radiation high background radiation something to do with half-life? Think about it. Don't say it. 60 minutes. 怎么样来的？这个没跟我聊。
100.
因为那个很多的
100 is
just a good operation.
This essentially counts per minute, right?
Yeah.
If this is the counts per minute, how much do you start out with? Okay. If let's say you do one half-life, how much would it be? Oh, so how long would it take? And right. Do the same concept for it's not 2 days for sure.
So,
Two pages only.
Yeah, just 2 pages. Guys, if you're done with the 2 pages, you're good to go already, guys. We'll discuss the answers next week, guys.
他跟我讲哦，他的笔数很少，
不要抄，不要抄，我的心我没有抄过。
谁的 physics book？ 谁的 physics book 更给？我要想看一看。
什么？还没抄啊
？Are you sure it's correct, Ivan?
Oh, is it irony?
You see inside?
No, I don't think he said it.
Why?
It's Marisa's pen.
没有啊，
一个两个 holiday 就不要来上课了。Okay, guys, for those who are online, we're going to end class already. If you have any questions, you are welcome to stay back and clarify your questions. If not, you can join the next MS class already, guys, or the chemistry class. Okay, welcome. Bye-bye.